Welcome students in the channel Easy and Simple Physics created by Joshi Sir Partur. In this channel we get online class for the standard 12th science for subject physics. Today we learn about the topic of application of uniform circular motion. In these applications, we see the horizontal and banked curved road surface. In case of horizontal curved road, two edges of road are at the same level, called horizontal. Consider a vehicle moving along a horizontal curved road with radius r. Let mu s be the coefficient of static friction of road and tire of vehicle as shown in figure. We can see the figure. Let force of friction is Fs is equal to mu s n. Weight mg of vehicle is acting downward, which is balanced by normal reaction capital N. So static friction of force Fs is equal to mu s mg when vehicle is moving safely with maximum speed along the horizontal curved road surface. For circular motion, centripetal force is necessary, which provides force of friction. Therefore, centripetal force is equal to force of friction. So, mv square maximum upon r is equal to mu into mg. Mm get cancel. So, v square maximum is equal to mu r g. Take square root on both sides. Therefore, v maximum is equal to square root of mu r g, which is the maximum velocity with which vehicle is safely drive along horizontal curve road. Well or wall of death. Consider a vertical cylindrical wall of radius r. Inside the well, a vehicle is driven in a horizontal circle. Normal force capital N exerted by wall, which is directed radially towards the center inward, is called centripetal force. Therefore, capital N is equal to mv square upon r as shown in figure. The upward force of friction, which is static friction, is exerted by wall, is along upward direction, which is balanced by weight. Therefore, Fs is equal to mg. Static force of friction is mu s n, where mu s is coefficient of static friction. If we substitute the value of n, so static force is equal to mu s in bracket mv square upon r. If substitute the value of static force, so mg is equal to mu s mv square upon r. Get cancel. Therefore, v square is equal to rg upon mu s. The motion of vehicle inside the well with minimum velocity is given by taking square root. So, v minimum is equal to square root of r into g upon mu s. We can also find out minimum frequency. Minimum frequency is equal to v minimum upon 2 pi r, which is equal to square root of r into g upon mu s upon 2 pi r. Let us see banking of road. Banking of road is an arrangement of road surface such that outer edge of road is raised by higher level than inner edge. Such arrangement of road surface is called banking of road. So the question is why banking of road is necessary. So we see that for circular motion, centripetal force provides force of friction between the wheels and road surface. On the road, when road surface is not banked, means unbanked, so force of friction is not reliable because its magnitude decreases when road becomes wet or oily. In rainy season, one way to increase the magnitude of frictional force to make it more and more rough, which causes wear and tear of tires. Hence, frictional force is not reliable to provide centripetal force for the safe motion of a vehicle on a curved road. But if road surface is banked, then the horizontal component of normal reaction provides the centripetal force on curved road surface. Due to this reason, banking of road is necessary. Let us see angle of banking. The angle between the banked road surface and horizontal surface is called angle of banking. We see an expression for most safe speed, means not a minimum or not a maximum, that is optimum speed for which vehicle or car is safe on banked curved road surface horizontally. So we see the expression that consider a car or vehicle of mass m is moving with safe speed or optimum speed Vs on a curved banked road surface of radius small r, making angle theta with horizontal called angle of banking is shown in figure. In this figure we have seen two forces acting on a vehicle or a car such that number 1, weight of car or vehicle mg acting vertically downward. Number 2, normal reaction capital N is perpendicular to the surface of inclined plane, surface of road. So normal reaction is resolved into two components along vertical and along horizontal. So the component n cos theta is along vertically upward, which is balanced by weight mg. Therefore n cos theta equal to mg. Unbalanced component n sin theta is acting towards the center of circle called centripetal force. For circular motion, centripetal force is necessary, which is balanced by n sin theta. Therefore, n sin theta equal to mv s square upon r. Let us see using equation 2 and 1 their division So equation 2 divided by equation 1 is n sin theta upon n cos theta is equal to mv square upon r upon mg. N and mm get cancelled. So sin theta upon cos theta equal to Vs square upon Rg. Therefore, tan theta is equal to Vs square upon Rg. Therefore, Vs square is equal to Rg tan theta. And therefore, we take square root on both sides. So, Vs is equal to square root of Rg tan theta, which is equation A. And therefore, if we take inverse function, so theta equal to tan inverse in bracket Vs square upon Rg. Equation B. Means equation A represents expression for shape speed, whereas equation B represents expression for angle of banking. Actually or practically, vehicle is not traveled exactly with optimum speed. So there is a speed limit. Component of static force of friction between tire and road surface. Case 1, we can see that if V1 is speed or velocity of vehicle, so V1 is less than square root of Rg tan theta. So mv1 square upon r is less than n sin theta. In this case, direction of force of friction between tire and road surface is directed along the inclination of road. Force of friction F is resolved into two components, F sin theta and F cos theta. The component F cos theta is acting horizontally, which is parallel to n sin theta. In opposite direction, whereas component F sin theta is acting vertically upward, which is parallel to n cos theta. From figure, we see that F sin theta plus n cos theta equal to mg. We know F is equal to mu into n. Substitute the values. So therefore, mu n sin theta plus n cos theta equal to mg. Take n common. So n in bracket mu sin theta plus cos theta bracket close is equal to mg. And therefore, we see that n sin theta minus f cos theta equal to mv1 square upon r. So n sin theta minus mu n cos theta equal to mv1 square upon r. Take n common, so n in bracket sin theta minus mu cos theta equal to mv1 square upon r, equation 4. Divide equation 4 by equation 3. Therefore, n and mm get cancelled in the equation by division. So equation becomes sin theta minus mu cos theta upon mu sin theta plus cos theta is equal to v1 square upon rg. Multiply and divide by cos theta on right hand side of above equation. Therefore, cos theta upon cos theta in bracket sin theta minus mu cos theta upon mu sin theta plus cos theta bracket close equal to v1 square upon rg. Take cos theta in bracket, so we can write bracket sin theta upon cos theta minus mu cos theta upon cos theta upon mu sin theta upon cos theta plus cos theta upon cos theta bracket close equal to V1 square upon Rg. So cos theta get cancel and sin theta upon cos theta becomes tan theta. Therefore in bracket tan theta minus mu upon mu tan theta plus 1 is equal to V1 square upon Rg. If multiply Rg, then V1 square is equal to Rg in bracket tan theta minus mu upon mu tan theta plus 1 bracket close. Therefore V1 is equal to square root of Rg in bracket tan theta minus mu upon mu tan theta plus 1 bracket close. If mu is greater than or equal to tan theta, then V1 is 0, which is minimum, which is for a rough road surface. Case 2. If V2 is velocity of vehicle or car, V2 is greater than square root of Rg tan theta. So m V2 square upon R is greater than or equal to n sin theta. In such case, we have seen force of friction between tire and road surface is directed along the inclination of road surface. So force of friction is resolved into two components. Component F cos theta is acting towards the center, which is parallel to n sin theta, and component F sin theta is vertically downward to n cos theta, which is parallel as shown below. Here in this figure we have seen n cos theta, n sin theta, f cos theta and f sin theta. So from this figure an equation can be written as n cos theta is equal to f sin theta plus mg. Therefore n cos theta minus f sin theta equal to mg. So f is equal to mu n. If this value can put, so n cos theta minus mu n sin theta equal to mg. Take n common, so n in bracket cos theta minus mu sin theta is equal to mg. Therefore n sin theta plus f cos theta is equal to m v2 square upon r. Therefore n sin theta plus mu n cos theta equal to m v2 square upon r. Take n common, so n in bracket sin theta plus mu cos theta is equal to m v2 square upon r. Equation 6. Divide equation 6 by equation 5. Therefore we can take the equation such that n sin theta in bracket n in bracket sin theta plus mu cos theta bracket close divided by n in bracket cos theta minus mu sin theta is equal to m v2 square upon r upon mg. So cancel n and m. Therefore sin theta plus mu cos theta divided by cos theta minus mu sin theta is equal to v2 square upon rg. So multiply and divide cos theta to left hand side of above equation. So cos theta upon cos theta in bracket sin theta plus mu cos theta divided by cos theta minus mu sin theta bracket close is equal to v2 square upon rg. Separately divide cos theta. So in bracket sin theta upon cos theta plus mu cos theta upon cos theta divided by cos theta upon cos theta minus mu sin theta upon cos theta, bracket close. So cos theta get cancel, which is equal to V2 square upon Rg. So in bracket tan theta plus mu divided by 1 minus mu tan theta, bracket close, equal to V2 square upon Rg. So therefore V2 square is equal to Rg in bracket tan theta plus mu divided by 1 minus mu tan theta, bracket close. Here condition, if theta is equal to 45 degree, then tan 45 degree equal to 1, and mu equal to 1, then V2 equal to Rg in bracket square root tan theta plus mu divided by 1 minus mu tan theta. Therefore, if mu equal to 1, so V2 becomes infinity, which is maximum. Means velocity will be maximum. For heavily banked road surface, minimum limit may be imparted. But if mu equal to 0, no force of friction, then in both case V1 equal to V2 equal to square root of Rg into tan theta, which is the safe or safest speed of vehicle or a car moving along a curved banked road surface. So we can find out angular velocity. We know angular velocity omega. We know V equal to R omega. So omega equal to V upon R, which is equal to square root of Rg tan theta divided by R. If R can be taken in square root, so here omega is equal to square root of Rg tan theta upon R square. RR get cancel. So omega is equal to square root of G tan theta upon R. Question can be seen. If the static friction is 0, can a vehicle move on a road? Explain. So answer is, if mu s is equal to 0, then V maximum is equal to square root of Rg tan theta. Without friction, a vehicle cannot move on road surface. Another question. Explain why cyclists lean inward while taking a turn along a horizontal curved, means unbanked road. Answer will be, when cyclist taking a turn along a horizontal, means unbanked road surface, then he bends slightly from its vertical position towards the inner side of the curve. If he lean inward, so centripetal force required for circular motion, which is provided by horizontal component of normal reaction to the cyclist and vertical component of normal reaction, balance the weight of cyclist. But if he does not leans inward due to absence of centripetal force, he will lose his balance and will thrown outward. Question. Another question can be seen, on what factor angle of banking does not depends. So we know that angle of banking does not depends on mass of vehicle because mass is absent. So theta is equal to tan inverse in bracket V square upon Rg. Another question is seen. State the formula for number 1, minimum or lower speed limit of car which is safely drive on curved bank road, and number 2, maximum or upper speed limit of a car which is safely drive on curved road surface. So two questions can be seen here. Minimum possible or lower speed limit of a car is, minimum speed key is V minimum is equal to square root of Rg in bracket tan theta minus mu s upon 1 plus mu s tan theta, which is minimum possible speed limit of a car. But we can see maximum possible means upper speed limit of a car, which is maximum. So V maximum is equal to square root of Rg in bracket tan theta plus mu s upon 1 minus mu s tan theta bracket close. Means, so velocity of car becomes maximum. Here another question can be seen, on what factor maximum speed on curved banked road is depend. So answer is V maximum depends on number 1, radius of curved banked road R. Number 2, angle of banking theta. Number 3, acceleration due to gravity small g. And number 4, coefficient of static friction. In this factor, these factors, maximum speed on curved bank road will be depend. Another question is seen. The question will be, what will be the value of angle of banking if maximum speed or maximum velocity is equal to infinity? So answer is, if the angle of banking theta equal to 45 degree, then tan theta is equal to 1. So mu s is equal to cot theta, and so V maximum becomes infinity. Mu s becomes 1. If mu s is 1, V maximum is infinity. Another question is seen. Distinguish between banked curved road with friction and banked curved road without friction. Means we can difference with friction and without friction banked road. So first point in with friction is speed of circular motion of vehicle depends on R, radius of circular path, G, acceleration due to gravity, theta, angle of banking, and force of friction. Here without friction, number 1, speed of circular motion of vehicle depends on R, radius of circular path, small g, acceleration due to gravity, and theta, angle of banking. So second point can be seen. Weight of vehicle is in with friction. Weight of vehicle is mg equal to n cos theta minus f sin theta. Whereas in without friction, weight of vehicle is mg equal to n cos theta. We see centripetal force in with friction is mv square upon r equal to n sin theta plus f cos theta. But the centripetal force without friction is mv square upon r equal to n sin theta. Fourth point can be seen. Optimum velocity of vehicle on banked curved road is, in with friction, V maximum is equal to square root of Rg in bracket mu plus tan theta upon 1 minus mu tan theta, bracket close. Whereas without friction, optimum speed V maximum equal to square root of Rg tan theta. And fifth point is, if mu s equal to 1, then V maximum becomes infinity, is equal to 0. But in without friction, if mu s is equal to 0, then V maximum equal to Rg square root of tan theta. Another question can be seen, which is distinguish between horizontal curved road and banked curved road without friction. So two columns are there, horizontal curved road and banked road without friction. Number one, the first point in horizontal curved road, that is two edges of the road are horizontal, that is the same level. Whereas in banked road, one edge of road is raised higher level than other edge, that is inclined level. Number two, speed of circular motion of vehicle depends on force of friction, that is force equal to mu mg. Whereas speed of circular motion of vehicle depends on angle of theta, radius of curvature and acceleration due to gravity. Third point is weight of vehicle mg equal to n in horizontal curved road, whereas in banked road weight of vehicle mg is equal to n cos theta. Centripetal force. In horizontal curved road, centripetal force provides force of friction, mu mg equal to mv square upon r. In banked road, centripetal force is provided by n sin theta. So mv square upon r equal to n sin theta. Fifth point is maximum speed of vehicle. In case of horizontal curved road, V maximum is equal to square root of mu rg. Whereas in banked road, V maximum is equal to square root of rg tan theta. Sixth point is, for a curve horizontal, V maximum is less than V maximum for banked curve. But in banked road, for a curve, that is in bracket banked, V maximum is greater than V maximum for horizontal curve. And last point is the elevation. In horizontal curve road, h of outer surface with respect to inner surface is 0, means h equal to 0, whereas in banked road the elevation h of the outer surface with respect to inner surface is h equal to L sin theta. We have seen expression for banked road. When a road is banked, then outer edge of road is raised or increased higher level than inner edge. See the figure. Let width of road is L, height of outer edge of banked road from inner edge is h, theta be the angle of banking. If these points are seen from figure, we see that in right angle triangle, sin theta equal to h upon L. So theta is very small, so h equal to L sin theta, or sin theta is approximately equal to theta. Therefore, height of inclination in banked road, that will be h equal to L sin theta, which is expression for height of inclination for curved bank road.